Hello, welcome back to my YouTube channel. Today I'm going to take you through chemistry. Our subtopic today is about radicals, and I'm going to begin with the definition. The definition of what is a radical. And a radical is a group of atoms of same or different elements that combine chemically and that behave as a single unit with a positive or negative charge. So, a radical is a group of atoms of the same. It might be the same element or different element combining together chemically and behave as a single unit, behave as one unit with a positive or a negative charge. So for it to qualify to be a radical, it must have a charge that is either positive or a negative charge. So that is the definition of a radical. And radicals are totally different from compounds. Radicals and compounds are totally different. So what is the difference between a compound and a radical? So for radical and for a compound. Compounds are also groups of atoms of the same or different elements that chemically combine together and behave as a single unit. But for compounds, it has a neutral charge. And for radical, it's either a positive or a negative charge. Positive or negative charge. So this is the difference between a radical and a compound. Both of them have a similarity, and their similarity is that both of them, they are a group of atoms of the same or different element that chemically combine together and behave as a single unit. But for a compound, it has a neutral charge. That is only the distinguishing difference. It has a neutral charge, but for a radical, it has a positive or a negative charge. So let us look at examples of radicals. We have several radicals, but let us look at the examples. Example, I'll begin with ammonium. Ammonium is a radical. Remember, it's ammonium and not ammonia. Ammonia is not a radical, but ammonium with an IUM, it's a radical, and it's written as NH4 with a positive charge. This is the positive charge. Remember, for a radical, it must have either a positive or a negative charge for it to qualify to be a radical, and this is for ammonium. So that is it. Let us check, or let us know, how does this positive charge the positive charge is for the overall radical. Remember, the valency of nitrogen, it's -3, and the valency of hydrogen, it's +1. And remember, there are 4 hydrogen atoms. So for each, I'll multiply by 4, and this gives me a -3 plus 4. It's equals to 1, +1. So this is now the charge, or this is now the overall charge of this radical. It's +1. So no need for me to write here 1, but I'll just present it as a sign or a charge. Now hydrogen and atom and nitrogen atom chemically combine together to form ammonium as a radical with a positive charge. We also have hydroxide. And for hydroxide, it's written as H0 and a negative, OH and a negative. So remember, oxygen has a valence of -2 and hydrogen has a valence of 1, and for this case we only have one hydrogen. So a negative plus a positive is equivalent to -1. So no need for writing this one here, but it's represented with this sign here 1, and therefore it's the overall charge for the radical hydroxide. So this is how we write hydroxide as a radical, and this is how we write ammonium as a radical. Let us now look at sulfite and sulfate. They are also radicals. This is now sulfite and this is sulfate. Both sulfite and sulfate have a negative charge. They both have a negative charge of 2, -2 and -2. They have a negative charge. Here comes the difference. I have suffix "ite". The suffix "ite" and "ate" shows the presence of oxygen atom in that radical. So for the suffix "ite" shows the less oxygen atoms in that radical. And for the suffix "ate", that is in sulfate, shows the more oxygen atoms in that radical. So this is a note. For sulfite, the suffix "ite" shows less oxygen atoms in that radical, and for sulfate, the one with an "ate" shows more oxygen atoms in that radical. So note that for sulfate and sulfite, note the difference. This is also applicable in nitrates and nitrates. Let me write nitrate. This is a nitrite. And this is a nitrate. Both of them have a charge, a negative charge. It's 1, so no need for us to write 1, but writing this negative charge is the overall charge for the radical. So the suffix "ite" shows the lesser oxygen atom in that radical. And for nitrate, the "ate", the suffix "ate" shows more oxygen atoms in that radical. So whenever you see the suffix "ite" and "ate", note that it represents or it shows the presence of oxygen atom in that radical. This is also applicable for phosphates and phosphite. And phosphite is being written as this is for phosphate. So you can check whenever we have an "ate", the suffix "ate", we have more oxygen atoms. Where we have the suffix "ite", we have lesser oxygen atoms. So you can check for phosphate, you can also check for nitrate, you can also check for sulfate. The oxygen atom is more than for sulfite. So that is the difference, and you can note that. So let's check for carbonates. Carbonates are also radicals. So for carbonates, and it's written as with a -2 charge, and remember the charge is for the overall radical. We also have another radical, a bicarbonate. Bicarbonate, it's also a radical, and it's written as with a negative charge. So we have a difference between a carbonate and a bicarbonate. We can see the difference. This is now the prefix. This is the prefix, and it's a carbonate, and it's a bicarbonate. The presence of bi indicates the presence of hydrogen atom in that radical. Whenever you see the prefix bi, just know it indicates the presence of a hydrogen in that radical. Another visible difference is their charge. For carbonate, it has a -2 charge, and bicarbonate, it has a -1 charge with the presence of hydrogen atom in that radical. This is also similar to sulfate. We have sulfate. Remember, it's a sulfate. With a -2 charge, and we have a bisulfate with a negative charge. So this is bisulfate. This is now the prefix bi, which indicates the presence of hydrogen atom. So whenever you see a prefix bi, know that it indicates the presence of hydrogen atom in that radical. So this marks the end of our video today. Remember to like, subscribe, comment down below, and let's meet in our next video. Bye bye.